Hello everyone. In this video I'm going to show you a simpler version of a Mind Machine circuit that you can build with the LittleBits electronics building blocks kit. And in the first video I used quite a few pieces from the Korg synth kit. In this one I'm just using the oscillator, and I'll show you a version that uses really even a cooler principle than that, but let's just start with the oscillator. So I've also added much brighter LEDs using the bar graph. So those are broken out on a split wire, and when they're close to the eyes they are very, very bright. Really comparable almost, or at least within the ballpark of what you would get from a real Mind Machine. So we'll look at those in a little bit of detail, but first let's just look at the signal chain. So in this case I've got the power module that you need, and it's running off the 9-volt battery. Now LittleBits you can power from a USB connector, but conceivably, since we'll be putting these close to our eyes, maybe mounted in glasses or something, don't use the USB power. It's not safe to have, that type of unregulated, unknown connection close to delicate parts of your body. So use the 9-volt battery, and of course you don't want to shock yourself with that either, but in this case this is going to have to exercise some discretion. I wouldn't really recommend this for kids, because you're putting things close to your eyes, and you would want to electrically tape these together so they hold together and stuff. There's not considerable risk, but there is a lot more common sense and best practice required. But anyway, I'm just here to show you the circuit so you can learn to play with Mind Machines. Alright, so what we have here is I have the Korg pitch oscillator that we've used in other circuits, and it controls the pulsing of the LEDs. So however you set its pulse, then the LEDs will blink at that. And then I just have a split wire, give these some separation, and if you were to build them into glasses or something, then you would probably trim 2 parts in these wires and then splice in a longer wire would be the easiest way to do it, because making these tiny little JST type connectors is not too fun. So the easiest thing to do is just splice in wires. The hardest part of this kind of circuit is this battery's heavy, and they're magnets, so they want to pop apart. But if you tape them together, and definitely tape these connections that would be in the glasses, tape those together with electrical tape, and you'd be okay. So that is the simplest circuit. Now you see we've eliminated several components. We don't have sound currently, but I'll show you in a moment how to do that. All right, I just want to briefly show you what these bar graphs are like. So I have a dimmer here, and the dimmer in this case of the bar graph, see there's actually 5 LEDs, and they're green for 3, and then a yellow, and then a red. Very hard to film. But if I turn it up, the dimmer, see now I'm on 3, 4, and then the last one. So it's hard to tell. I mean, these are hard to film. But basically you have 3 green, an orange, and a red. And I don't see any way that I'm going to be able to film that, honestly. That's about as best as I can do. So they're bright. They always go at full brightness but more or less will come on depending on the power that's being fed to them. All right, so that's the simple type light circuit. Now, an easy way to add sound is with this buzzer. Before we used pitch oscillators and the speaker and all that kind of stuff, which was cool, but it added to the cost. So to get into a lower cost range, we basically just need this buzzer. Now see, that buzzer has a tendency to saturate sometimes, and it'll get a little squeaking sound. Which is actually kind of funny. But if it's mounted where it's held down, and it is a piezo buzzer, so it can kind of do a bone conduction thing. If you place it up against your head or at a bone near the ears, it'll kind of do a bone conduction thing, which is interesting. Now, I've measured the frequency of this with the iPad app. Let's see, I'm going to get the iPad app on. Just a moment. See if you can see that. So there's the iPad app. And so it's showing me it's basically just above 400. So I would call it at about 420 hertz. Yeah, so about 420 hertz is the frequency of that. And that'll become important in a later thing that I show you. Again, what it's doing is it's oversaturating as it bounces when it's not mounted down. But otherwise it creates a pretty nice little isochronic pulse to it. And as we determined, it's around 420 hertz. So it's kind of pleasing. So that's just the buzzer itself, and it's just a standalone module. No speaker or anything like that. So there is a way to add simple audio. Now let's look at another cool thing that we can do. So let's take out the oscillator here, which was our pulse, and let's add a microphone bit. Okay, and the microphone bit has a mic, and then it has a headphone or an audio input. And then it also has a switch that chooses a sound output or other output. We want other because we're going to use it to create a signal with. So when I do this, let me get these other modules out of my way. Now I can take my iPad here. Okay. You're going to see the light probably. Yeah. This is going to be weird to film. I'll just have to do my best to show you. But let me get my app. This is an app that I made to create monaural or to create audio strobe with. And it runs in an environment called ModuPlay. Alright, so here's the app, and we only need to use the tone function from it. So audio going out of the iPad into the microphone bit using this app. Try to turn that. Got it like a ring light. All right, so let's see if we can see all that together. Sort of. Alright, so I just turn it on now. I only need the tone, and I'll set the volume. Okay, so I set the volume and the tone. These are audio strobe, but the red frequency is the tone. So I'll turn that up, and then the pitch of the audio we determined is best at about 420, because that's the resonant frequency of that piezo element, right? So turn my tone up. This is a free app. All right. So I can control it now. And read the frequency, you know, so 6 hertz, 10 hertz, 12 hertz, and so on, controlled by the app. Now I could make a special version of this app that's just the tone control for this very function. But with an audio out of an iPad or iPhone, it also works iPhone, Android. Then there you go. You've got a controllable pulse. And then you have this kind of isochronic beat deal that works. So that's pretty cool. All right. So that's out of the iPad. Now, also, all right, also it's going to work with computer software. So something like Mind Workstation or any Audacity, any free kind of isochronic beat generator. Again, the optimal pitch in this case is 420. If you cared about, too many hands required. Come on. If you cared about getting the piezo to pulse, let me get this out of the way. So there's Mind Workstation running. Lamp behind me. But let me play it. And again, I've got the pulse. Now I could stand to turn up the volume a bit. There we go. So I could make as really complex of a session as I wanted if I went through and just generated a bunch of random nodes, let's say every 0.2 seconds I'd make a new node, or 0.2 minutes, from 1 to 20, end up with that kind of structure, and then run it. Won't be able to show them both. Then I'm getting kind of a pretty elaborate show going on here. And again, when these are mounted in glasses, then they're within the ballpark of a Mind Machine. If you had, you know, some kind of audio splitter or something and you're playing a media file, you wouldn't really be able to mix music into your session. You'd have to stick with isochronic beats if you wanted it to pulse. And you'd be stuck at a certain tone. So it's just kind of a hack, just kind of a workaround of something that's possible to do. But, you know, this one, you know, the microphone bit may be like $15 or $18. And each one of these bar graphs might be let's say 15, so that's 30. That's, you know, close to 50 bucks. It is about 15 bucks. You know, so it's probably about $60 or $70 shipped. Plus, you know, if you already have the software or whatever. So once again, it's not like it's economical. It's not like you know, by the time you do glasses and things, you're not going to save a ton of money for what you would say get on a entry-level My machine like the Proteus. But it's still cool, and you're learning a lot from it on how it works. And, you know, it just shows you the realm of possibilities that you can do. So that is my second revision My machine using LittleBits, and I've got some plans to add some other modules to it to try to do some cool stuff. And if I come up with something more seeing, I'll be sure to share it with you. So take care, and thanks for watching.